Right, continuing the previous videos that discussing about the QED, we'll talk about um, some of the additional materials and some of the things about the QED, especially some of the derivations for the propagator for the internal line in the Byman diagram. That was first topics of the today. And the second one, how can we sort of times the cross actions from the QED by using the spin summations and the Trice theorem as the scales of the amplitude, which is the time from the Byman diagram. So first of all, we want to derive sort of the propagators for the spinors and the factor and there are very tricky derivation here because this is not the QFT course. Our focus was on the particle phenomenology. Actually, the such as propagators that comes from the green functions of the free particle, like the free spinor for the Dirac equation, and the free vectors, like the some of the Maslow's gauge boson equation. And the one thing I want to mention is the important thing is the completeness relations as all possible spins tight and all possible polarization tight. So first of all, in the spinor case, we want to obtain about the complete relations for the all possible spins tight. So the spinor, free spinors follows the Dirac equations, and then the two component representations, the Dirac equations are following with the power matrix from the gamma matrix, gamma I, and the minus m, and the such as inner products between the Bohr momentum and the power matrix given like that. If we start the Bohr momentums aligned to the jet directions during momentum with energy. And then the such a Dirac equations with the matrix forms can be written by the 4x4 matrix with the component with the energy E and the jet directions to momentum P jet. So, and if we solve such a matrix equation linear system, the solution is given by the functions of energy and the jet directions momentum. And if we try some of the basis, spin base 10001, then we can obtain some of the compact form of the Dirac equation solutions in terms of the momentum and some of the spin state. And the very compact form in a product of the momentums and the power matrix. Then if we find some of the complete relations of the outer product, so that this is actually the psi bra and the psi cut, such as US and the US bar, and the summations of the all possible spin. Then the such as joint spinors actually is the gamma G's psi dagger. So such a gamma G matrix will be inserted. And if we calculate such summations of the outer products, the results are given by the gamma matrix and the Bohr momentums P mu plus M. So the spin summations of the spinor is given by the P bar plus M. And for the anti-spinor, antimatter spinor V and the V bar, spin summations are given by the P constants minus M. And it will be used to derive sort of the propagators of the spinor. And similarly, we can derive for the complete relations of the proton polarization state, but there are two cases. The first sort of for the mass proton case, the possible polarization state is there are three states. The first one is left-handed circular polarized state, and the next one is the right-handed state. And if we align the momentums with only the non-balancing jet directions of the three momentums to satisfy the polarization condition, so the Bohr momentums and the polarizations contractions between them should be equal to 0. And there are one additional positive polarization state for the mass photon case, which is called the longitudinal state. Such a state, in the energy component, there are p jet is located, and in the momentum's just directions, the energies will be his, and such a p jet and E is a swap. So it satisfies such a condition. Contractions of the ball momentums and the polarization state become to 0. So such a longitudinal state is possible, but the mass be photon case with the normalization with 1/m. But in the massless case, such a longitudinal polarization state is that is the fear. Actually, such a degree of avoidance of the additional polarization state will be evidenced by the will be becomes the gauges to freedom. Actually, such as three polarization can be interpreted as the three spin states for the 1 plus minus 1 and the 1 juice in the quantum mechanics, such as spin JM state. So if we calculate such a complete relations of the spin state or polarization state of the photon. So the outer products of the polarization state and summations with all positive polarization. Then for the right hand is and left hand is circular polarization state and the longitudinal polarization state. And then if we rearrange each term, all the energy and momentum mass terms in this second term, then we can derive the complete relation to the polarization state for the general directions of the ball momentum is given by there will be the first term given by the minus g mu metric tensors and the plus q mu q nu over the m square, where the q is the momentum of the ball momentum of the massive boson. And in the massless photon case, the second term will disappear, so which comes from the longitudinal polarization state. So the such complete relations of the photon polarizations given by just minus c mu. So such a both massive and massless photon complete relation, but the polarization will be also used for the deriving of the photon propagator. So already we derived such a propagated in the previous video as a QED Byman rule, as here. So from the QED Lagrangians, free protons and the free fermion or free electron, we can reduce the Byman diagram for the internal line. This is a photon propagator, and such a genius comes from the complete relation for the photon polarization state, and there will be the q squares minus m squares, and then the numerator there will be the q plus m, which comes from the complete relations or spin summations of the fermions or spinor. So it can give us such a I over the q bar m, q plus minus m, which is for the fermions propagators. Next, we want to talk about some of the additional technique in the QED calculation, which is called the spin summation or the Trice theorem. Our focus on the one specific example, the electrons, positron, and in relation to the muons and antimuon. We want to extract some of the mass, momentum, energy information in the amplitude to obtain some of the cross-section, which is the real observable quantity in the particle physics. And such a cross-sections will be functions of some energy, which can be measured in the detected experiment. And actually, such information of the mass, momentum, energies that are stored in the solutions of the spinor or some of the polarization states of the photon. So there's such a spinor, there are four component spinor. It contains such a mass, momentum, and energy. And also we can calculate the amplitude m by using the explicit solutions to the Dirac equation, but we will use some of the very practical some of the trick or practical technique, which is called spin summation, which with the assumptions with the all the spins that have the same probability, so that their unpolarized state will be quite clear. So first of all, rather than the spin summation, the direct method to obtain the spin summation is by using the helicity state. So we can know that the such helicity state as a solution of the Dirac equation, and if we insert that the helicity state in the amplitude, then we can obtain the some of the angular distribution or other distributions of the cross section. So first of all, if we consider that the initial particles, one is the right-handed and other one is the left-handed, and the binary test, one is the right-handed and other one is the left-handed. Then we can draw the such helicity ties with the momentum direction. So this is the momentum direction of the initial particle one, and this is the momentum direction of the initial particle two. And the right hand is aligned to the spin directions of the momentum, and left hand helicity, and the helicity is the different opposite lines with the momentum and the spin. And also for the binary side, left-handed and right-handed. And if we calculate such RR goes to the RR, then by the momentum conservations, it prefers the setas smaller than the pi over the 2 with the 1 plus cosine theta scale. And for this, the helicity swap or helicity flip process, RR go to the LR process. It refers to the setas is larger than the pi over the 2, less than the pi. Or to because to satisfy this angular momentum conservation. This is the initial particle angular momentums, and if the error goes like that, then it prefers such as backward scatterings. And I want to talk about the very briefly about the chirality, which is the eigensize of the gamma matrix 5. So we can construct sort of the projections applied to in terms of the gamma pi matrix. In the bar representations, the gamma pi matrix are given like that. And the properties of the gamma pi matrix commutative and relations, and it is the square of the gamma pi is equal to 1, and by that we can deduce the many identities of the projection applied to the scales are equal to 1, and the PR and the PR got used. There's a very reasonable properties for the proper projections applied. And for the adjoint pinner, psi R, psi R, psi R1 and psi R go to 0. So the left and the right hand is the orthogonal. So and if there is the gamma mu as some of the current form, then the psi L and the psi L bar becomes 0. So the in the Lagrangians, the psi R bar and the gamma mu psi L will be the bound. And the such helicity starts, the chiral starts will be the difference, but in the relativity limits, the helicity and the chirality becomes a sign. If we act through the projection applied to the helicity start, there will be some of the right-handed chirality and the left-handed chirality start, but such a left-handed chirality start will be the disappear strips in the relativity limit. And maybe this now I want to talk about the twice theorem, but maybe always keeps it in the next time about such a twice theorem. There are many remaining things. So first, we discussed about the complete relations of the spin summation for spins, possible spin state for the fermions and the positive polarizations of the boson. And also, we talk about how can we use the holistic as a solutions of the Dirac equations. It can be used for the of signed angular distributions of the QD scattering. And also, we talk about the chirality very briefly. That is the difference with the holistic. And maybe this the next video we talk about the symmetric theorem as one of the very useful techniques to obtain the another dependence the cross sections in the case is scattering by using the spin summations, and already we derived the spin summations through such a fermion state. And maybe later we talk about the twice theorem to obtain the spins unpolarized spins averages is the scarce amplitude.